good sources of energy. We all know that we need energy to work. But where do we get this energy from? We derive energy from various different sources. Let us have a look at some of these sources of energy. The trains run on energy from the diesel. We use petrol, diesel, and CNG, that is, the compressed natural gas to run cars, buses, and other heavy vehicles. The energy from electricity is used to light our street lamps. Likewise, we use muscular energy for doing physical work, electrical energy for running different appliances, and chemical energy for cooking food or running a vehicle. All these forms of energies come from various sources. But how do we choose the best source for obtaining energy in its usable form? This question arises several other doubts like: why is CNG preferred over petrol or diesel for running vehicles? Why is kerosene oil or coal not preferred for cooking food? Let us discuss the factors that help in selection of the source of energy. Selection of a source of energy or fuel depends on many factors such as the amount of heat it releases on burning, the amount of smoke it produces, and availability. Characteristics of good fuels. A good fuel is the one that produces a large amount of energy per unit mass. This means that a good fuel has high calorific value. Also, a good fuel must have an adequate ignition temperature. This means that the ignition temperature should not be too low, as in case of white phosphorus, or too high as that of wood, since it requires a lot of heat or energy to ignite. It should also be pollution-free, thus not producing smoke on burning. And also, it should be available easily. Easy storage and transportation is another key factor that determines whether a fuel is good or not. LPG is a fuel which exhibits all the characteristics of a good fuel, thus is used as an ideal fuel. Sources of energy. We use different sources of energy in our daily life for various activities. On the basis of their use, these sources of energy are grouped into conventional sources, and non-conventional sources. Conventional sources of energy. The sources of energy used since ancient times that meet a major part of our energy requirement are called conventional sources of energy. Fossil fuels such as coal, petrol, natural natural gas, wood, wind energy, and energy of the flowing water, that is hydro energy, have been harnessed as potential sources of energy since ages. The growing demand for energy is largely met by fossil fuels such as coal and petroleum. It takes millions of years for these fossil fuels to form, and also there are limited reserves. The fossil fuels are non-renewable sources of energy. Their consumption at such alarming rates would make us run out of these sources of energy soon. Thus, there is a need to conserve and use these resources judiciously. Burning of fossil fuels produces oxides of carbon, nitrogen and sulfur. These oxides are acidic in nature and lead to acid rain, which adversely affects our water and soil resources. The combustion of these fuels also leads to an increased production of carbon dioxide, thus leading to the greenhouse effect and hence the global warming. Besides being used in gas stoves and vehicles, fossil fuels are also used as a major fuel in generation of electricity. For generating electricity, large amounts of fossil fuels are burnt every day in power stations to heat up water for producing steam, which further runs the turbine, thus generating electricity. With technological progress, our demand for energy is increasing day by day. With the demand for energy growing at the current rate, one can't just depend on the limited and non-renewable reserves of the conventional sources of energy. So there is a need to look out for new alternate sources of energy. These alternative sources of energy are also known as non-conventional sources. Some important examples are solar energy, energy from the sea, ocean thermal energy, geothermal energy, and nuclear energy. Solar energy. The sun has been radiating an enormous amount of energy at the present rate for nearly 5 billion years and will continue to do so for another 5 billion years to come. Of the total energy radiated, only a small part of solar energy reaches the Earth's surface. Devices such as a solar cooker or a solar water heater function by tapping the solar energy. To absorb maximum heat, these devices have black surfaces. Some solar cookers are also fitted with mirrors to focus the rays of the sun in order to achieve higher temperatures. They are covered with a glass plate to trap the heat radiations and facilitate heating. But an associated limitation of using these solar devices is that these devices can be used only at certain times during the day. This limitation of using solar energy is overcome by the use of solar cells that convert solar energy into electricity. A typical solar cell develops a voltage of 0.5 to 1 volt and can produce about 0.7 watts of electricity when exposed to the sun. Non-conventional sources, solar panel. Now let us see what a solar panel is. A large number of solar cells combined in an arrangement to deliver enough electricity for practical use. This arrangement of solar cells is called a solar panel. Now let us have a look at the various advantages of using solar cells. The principal advantages are: solar cells have no moving parts. They require little maintenance. They can work without the use of any focusing device, and the solar cells can also be set up in remote and inaccessible areas where laying of power transmission line is expensive and commercially not viable. But there are also some limitations of using solar cells. The manufacturing cost of solar cells is very expensive due to certain reasons such as availability of special grade silicon that is used in making solar cells is limited. The use of silver for interconnecting the cells in the panel further adds to its cost. This limits the use of solar cells in domestic purposes. However, they are used as the main source of energy in artificial satellites. Some other examples where solar cells are used are in radio or wireless transmission system or TV relay station in remote locations, in traffic signals, calculators. Unconventional sources, energy from the sea. We have already learnt about solar energy, one of the major sources of non-conventional energy. Let us now learn about energy from the sea, which is another potential non-conventional source of energy. Oceans are large water bodies covering 70 to 80% of the Earth's surface. The energy from the sea can be harnessed in three different forms: tidal energy, wave energy, ocean thermal energy. Tidal energy. The rise and fall in the water level in the sea due to gravitational pull of the moon on Earth results in a phenomenon called high tide and low tide respectively. The energy derived from these rising and falling ocean tides is called tidal energy. Be aware of how these waves are generated. The unequal solar heating of the Earth generates winds. And these winds, when blow over water, generate waves. Like tidal energy, it is also a renewable and pollution-free source of energy. Thermal energy. Now let us discuss about another important form of energy: the ocean thermal energy. The oceans and the seas are reservoirs of large amount of solar energy. This solar energy stored in the oceans in the form of heat is called ocean thermal energy, OTE. The sun warms the ocean water at the surface, and the wave motion mixes the warm water downwards to a depth of about 100 meters. The temperature difference between the layers at the surface and those at a depth of 100 meters ranges from 10 degrees Celsius to 30 degrees Celsius. This difference in temperature between the surface and the deeper water layers in the ocean is used to generate electricity. But how? The warm surface water vaporizes volatile liquids like ammonia. These vapors are then used to run turbines of generator to produce electricity. The cold water from the depth is pumped to the surface, which again condenses back the ammonia vapors to liquid. This process of harnessing the thermal energy of the oceans for generation of electricity is called Ocean Thermal Energy Conversion, OTEC, and the devices used for the purpose are called OTEC power plants. The electric power generated from OTEC is continuous, renewable, and pollution-free. Geothermal energy. Due to geological changes, molten rocks formed in the deeper hot regions of the Earth's crust are pushed upward and trapped in certain regions called hotspots. When the underground water comes in contact with hotspots, steam is generated. Sometimes, hot water from such regions finds outlets at the surface, which are known as hot springs. The steam generated at hotspots trapped in the rocks is employed in generating electricity by routing it to a turbine through a pipe. The geothermal energy is the naturally occurring thermal energy of the Earth that originates with the rock formation, from radioactive decay of minerals, and from solar energy absorbed at the surface. The geothermal energy is a clean and sustainable form of renewable energy, which is also cost-effective and environment-friendly. Though relatively inexpensive, the number of commercially viable hotspots is very few, thus rendering the exploitation of geothermal energy difficult. In India, the northwestern Himalayas and the western coast are regions with important geothermal sites. Nuclear energy. The energy trapped inside the nucleus of an atom is called nuclear energy or atomic energy. There are two distinct ways of generating nuclear energy. These are nuclear fission and nuclear fusion. Nuclear fission. Nuclear fission is the phenomenon of splitting of unstable nucleus of a heavy atom like uranium, plutonium or thorium into lighter nuclei with the liberation of an enormous amount of energy. The fission is carried out by bombarding the heavy nuclei with suitable low-energy neutrons. In this process, if the mass of the heavy nucleus is slightly higher than the sum of the masses of the lighter nuclei, then an enormous amount of energy is released. For example, the fission of an atom of uranium produces 10 million times the energy produced by the combustion of an atom from carbon from coal. In a nuclear reactor designed for electric power generation, this nuclear fuel can be part of a self-sustaining fission chain reaction that releases energy at a controlled rate. This released energy is used to produce steam, which is further used for generation of electricity. Nuclear fusion. Nuclear fusion is the phenomenon of fusing together of two or more lighter nuclei to form a more stable heavy nucleus with the liberation of vast amount of energy. The fusion of nuclei requires a considerably large amount of energy. Extreme conditions such as millions of degrees of temperature and an extremely high pressure are needed to bring about nuclear fusion. Do you know what is the source of energy in the sun? Yes, the nuclear fusion reactions are believed to be the source of energy in the sun and other stars. The hydrogen bomb is also based on the thermonuclear fusion reaction. The nuclear bomb based on the fission of uranium and plutonium is placed at the core of the hydrogen bomb. This nuclear bomb is embedded in a substance containing deuterium and lithium. On being detonated, the temperature of this substance rises to 10 to the power 7 Kelvin in a few microseconds. This high temperature generates sufficient energy for the light nuclei to fuse, thus releasing a devastating amount of energy. Although a potential alternative source of energy, nuclear radiations have some serious deleterious effects. Difficulty in nuclear waste storage and disposal limits large-scale use of nuclear energy. Other important factors that make the use of nuclear energy prohibitive are high risk of environmental contamination due to accidental radiation leakages, high installation costs of nuclear power plants, and limited availability of uranium. How long will an energy source last? I'm sure you all must be using electricity judiciously. And for those who do not, here comes some advice. We all must ensure a careful and judicious use of electricity. For this, we should all take care of the following things in our day-to-day life. We must switch off all the lights and fans when not in use. We should turn off the engine of our vehicle at red light. We should all try to minimize the usage and thus our dependence on the fuel by several other conservation methods. But have you ever thought why? Why use the source of energy carefully and judiciously? Why not use it as and when we want to? Because our dependence on fossil fuels for our energy requirement is vast. We are using them at a much faster rate than the rate of their formation. The fossil fuels take millions of years to form. Thus, the rate at which they are being consumed will lead to their depletion. Such sources which will get depleted someday are said to be exhaustible or non-renewable sources of energy. On the other hand, there are sources of energy which can be renewed or regenerated. Such sources of energy are called the inexhaustible or renewable sources of energy. Renewable energy is available in nature in the form of a continuous or repetitive current of energy. biomass, sun, water are all examples of renewable sources of energy.